How many times have I, and I'm sure a lot of you, thought, if only I had a tube extension socket so that I could test certain voltages and all that while having the tube in the circuit and working normally. Now, I went on to the internet and I had a look at how much, in my case, a 7-pin tube testing extension socket would cost. And quite frankly, I was appalled at the prices they go at. The cheapest I think I saw was something like $25, and the most expensive one went all the way up to $48. So after a frustrating look around and not having found anything that I could use at a reasonable price, I thought it would probably be worth spending a little money on trying to make one myself. And as you can see, I'm in the process of making one. Now, how to make these, if you have just a few tools and a little bit of patience, I think you can make quite easily one like this. The only thing you need is a brand new, preferably ceramic socket like this one, and some gold-plated brass wire like this, which is gold-plated 16-gauge brass wire. Now, I know some of you will say, well, hey, if I have to spend, say, $10 on gold-plated wire and another $10 on a socket, then I could just as well buy one ready-made. Well, yes, you probably could, but for that money I got a roll of 3 yards of gold-plated 16-gauge wire, which I can use for all sorts of purposes. In fact, I used a large piece of it to refurbish the Ever-Ready radio, and now I'm using it to make my test socket. Also, I had to buy a number of new sockets because, well, I needed a few to repair some radios. Now, the reason why I say you should better use a ceramic socket is because they are more temperature resistant. They won't expand or contract that easily under varying temperatures, and they are also more resistant to heat from a soldering iron. Now, there are a couple of things you should be aware of, and that is that most of these sockets, the lugs at the bottom move quite a bit. As you can see, they wiggle around a lot. Well, okay, maybe not a lot, but they do certainly wiggle around. Now, the way to reduce that wiggling is surprisingly simple. You just need to bend the lugs down like this, horizontally in other words, and then you drop quite a bit of solder at the base of each lug. When you do that, you already diminish the wiggle in the lug substantially. Obviously I'm doing this with one hand, but I think if you watch this, it already wiggles quite a lot less. Well, this one wiggles a bit more than this one, for example, but I'm not done yet and I still have to solder it. Now, if I use the right and appropriate amount of solder, you see that they don't wiggle any longer, which is of course exactly what you need to do. So when you bend these lugs in the right angle, and you see it's at right angles with the socket itself, then you need to cut little pieces of this gold-plated brass wire, and the length of the pieces is not critical, but I took a wire of about 2 centimeters, which turns out to be just right for putting the test socket into a circuit, because remember, this sinks about 8 mil into the socket, just like a regular pin of a vacuum tube would do. And it leaves this test socket about 1.2 mil, 12 mil, I want to say 12 mil above the original socket. As you can see, there is also this ground lug, so you do need a little bit of clearance, and I went for 12 millimeters clearance in total from the base of the socket. And here is the result. As you can see, I managed to grind with my mini grinder all the pins to, well, very close to equal size, as you can see. I soldered them as close as possible to what a real tube spacings should be of the pins. Now obviously the pins still do move a little bit and are not quite concentric yet, but I'll use one of the other loose fittings like these and put this one inside another fitting, so that the legs, which you see here, the pins, are all exactly at the right distance and spacing of each other. Once they are blocked in the right position, I will squirt a big drop of epoxy glue right in the center of the base of this test socket, and just for solidity purposes really. So I'll use quite a bit of epoxy glue to cover this whole base here with, oh, say roughly 3 or 4 millimeter epoxy, just to make it solid enough. Once that will be dry, I will give the endings of these pins a final polish with the tiny little grinding wheel I have on my mini drill. Now I'm aware some of you might not have a mini drill handy. In that case, you'll have just a little bit more work doing it by hand and with a little bit of sanding paper, or perhaps a nail file, and then you'll have to round the tips with a nail file or a little bit of sanding paper and quite a bit of patience, I admit. But once you're done, then you should have a functional test socket like I'm in the process of making. So good luck, have fun making one, and rest assured it'll come in handy. So stay tuned for another